Hi, this is Group 91, and today we are presenting our project on AI-powered detection of cyberbullying in the social media platform. The main motivation behind this project was to identify the growing issue of the social media bullying, which is happening in all the social media platforms, and it has led to several issues in the teenagers and in the adults as well, leading to several psychological distress, anxiety, and even social isolation as well. And current moderation methods heavily rely on manual efforts, which is kind of inefficient. So we kind of designed a AI powered based solution which can automate detection and mitigate, which helps in making the social media platform a better place and a safer environment for all the users. So for the data part, we have collected it from the Kaggle, and the name of the dataset is cyberbullying classification, and it has about 46,000 different rows, and it has two main key features, one being text and one being cyberbullying type. Text, it can either be a social media post or a comment, and cyberbullying type, it can be of six types like not cyberbullying, gender-based, religion, other cyberbullying, age-based, and ethnicity-based. And the input, again, as being said, it is text-based, so it's either from we have collected it from Twitter or X, and we classify the output variable either of the six cyberbullying types as previously mentioned. Now, Satvik will continue for the baseline model.
So hi everyone. So the baseline model methodology we have used and the steps we perform to train the model is the data pre-processing and then the text cleaning, which where we remove the URLs and mentions and mainly the special characters, and then the tokenizers, and then padding, which while ensuring all the input sequences are of length 100 for the uniformity, and then label encoding like converting the categorical variables into integer variables, and then the train test split, which is the 80-20%. And then for the model training, we have trained it for like 10 epochs with the batch size of 64, and the class weights are computed to handle the imbalanced data, ensuring the fairness in the classification. So for the baseline model description, our baseline model is bidirectional LSTM neural network. So it is well suited for the NLP tasks like text classification. So the model architecture that we followed is the embedding layer, which converts the tokenized words into dense vector representations. And then the bidirectional LSTM layers, which has like two layers. The first layer with 64 units to parse the sequential features, and second layer with 32 units to extract high-level representations. And then dropout layers and also dense layers. Dense layers is like fully connected, which has 64 neurons and ReLU activation. And final output layer with softmax activation. And then loss function and optimizer, which is like the Adam optimizer, which is used for efficient learning. And then we have the baseline evaluation metrics, and these are all the precision recall, F1 score, and all the metrics that we have used, and also the confusion matrix. So yeah, this is more about the baseline metrics. Now Vaishnav will take over.
Hello everyone. So we fine-tuned our model to BERT, which is another cyber detection model. This is for our leveraging using the BERT-based uncased architecture. We began pre-processing the data and tokenizing the tweets, applying a truncation and then a padding of maximum 128 length, generating higher and encoding labels. The data set was then split into the usual 80-20 split. We've used the BERT for sequence classification model with the classification head on the top of the CLS token embedded with the Adam optimizer. We use the Adam optimizer in this because it helped in our previous model as well. So we continued with it. And then we have this is next is our model description. So our model description is built on the BERT based, which includes like a 12 transformer layer over 110 million parameters, enabling it to generate a rich contextual embedding from the tweets. So the pre-processing pipeline begins with the BERT tokenizer that converts the raw tweets into subwords tokens and then prepares them for the input. The core of the model, BERT encoder, which captures the nuanced relationships within the text. On top of this, we add the linear classification head as told before with the CLS token embedding. Then for training, we have used cross entropy loss and we have used the Adam optimizer on top of it. All together, this a very it's a cutting leverages the cutting edge NLP techniques. So the performance in this was a little better than the BiLSTM, and I'll show you the metrics as well. So this is our confusion matrix over here. Then we have our scores, and we have the training over loss graph, and this is our references. So this is the demo for the project which we did. So let me put a statement over here. Hello, my name is Jeff. It's not a cyberbullying. Okay. And let me put another statement for you. So you can see it says it's other cyberbullying. So other cyberbullying means which does not, talk about the gender, race, or ethnicity or something. This is something that you just telling about someone's skill is very bad or something. So that's why it is termed as other cyberbullying. So yeah, that's it for our demo. Thank you so much.